Yes. Welcome to 9th International Symposium on Multidisciplinary Studies and Innovative Technologies. The conference is supported by IEEE Turkey section and also supported by Tokat Mladost University. We are in session 9.2 now, and we have 11 papers to be presented in the session. Each participant will have 10 minutes to present their studies. So the first paper ID is 159, an interpretable machine learning approach to decode event-related oscillation during motor imagery.
So I will be presenting that paper. Should I begin?
Yes, you can share your screen.
Okay. Can you all see my screen?
Yes, you can start.
Okay, thank you. So I'm going to, hi everyone, I'm Reshma Kaur. I'm from the Data Science Institute at St. Peter's University, New Jersey, USA. So today I'll be talking about an interpretable machine learning approach to decode brain oscillations during motor imagery. So before I start all this, I want to describe what EEG is, or electroencephalography is. So when the brain, the brain exchanges messages and enables us to perform our daily navigations by exchanging calcium, potassium, and sodium ions. And these ions create an electric charges inside our body as well. And so when we place electrodes on our scalp or even on any other parts of the body, we can actually measure some electric signals, and the specifically for head, these kind of signals are known as EEG. And so for EEG, what happens is that we place the some electrodes in specific points around the surface of the head, and we collect those signals so that we get the similar kind of signals from similar spaces near the brain every time. And in general, we have biosignals like EEG, which are 3N, which means they are non-stationary. So they cannot be explained with some fixed parameters. They are nonlinear, so cannot be expressed with a linear equation. And definitely they are very noisy. So the question is, why do we even select these noisy signals for our work? Now, one of the reasons, the main reasons, which is not mentioned in this slide, is because these signals have a very high temporal resolution. So, we can collect electricity travels fast, unlike the other signals like fMRI, which reflect. And so, it's easier to have like a quick analysis using EEG. Also, EEG is helpful for diagnosis and prognosis. So EEG has been, so diagnosis means that we detect diseases, and prognosis means we detect diseases even before they occur. So it's like predicting diseases. And of course, if EEG is a disease biomarker, then we can also use it for preclinical drug discovery. So by preclinical drug discovery, we mean that, if it is a disease biomarker and we can somehow test some drugs which reduce the disease biomarker, then we can say that this drug is effective. So it can be a part of preclinical drug discovery as well. And these are the applications of interpretable EEG analysis. Now, with that, I come to the oscillatory brain theory. Now, everyone has been trying to understand the brain, the brain scientists mainly, that, how does the brain work? And it is often like a black box. So some people formulated that, the brain, which signals through ions and, electrodes, has signals like this. And then this signal can be decomposed into various frequency bands, and these frequency bands can then be studied. So we have like low frequency bands like delta waves. So this EEG signal, which looks like this, can be decomposed into a slow wave, which is a low frequency wave, and it's delta wave, and this part of the signal will represent sleep. And then we have some other high frequency waves like beta waves, which represent movement, or some other particular things. And in between, we have some other frequency bands. So when we superimpose all these signals, we should get back the raw EEG as well. And so this is the main fundamental behind the oscillatory brain theory, that, the frequency, the EEG activity specific to certain brain signal frequency is studied, and these frequencies are known as oscillations. Okay, and then we come to data collection and cleaning. So first of all, we have, I would like to include the problem statement here, that although the oscillatory brain theory is a very solid theory and has been widely studied by researchers, the problem is that, if you search like beta activity, which is like this band activity for motor imagery, you'll find that, this is has been seen that beta activity predicts motor activity, but in some other papers you'll also find that delta activity predicts motor activity or alpha activity predicts motor activity. So which one is correct? Like, there is some confusion regarding this because scientists don't disagree, and that makes sense because EG signals, as we know, are non-stationary. So depending on the subject, these signals can change. So this is where our proposal comes. We try to understand not only what the subject is doing in terms of brain oscillations, we try to understand that which are the important frequency bands and the collection sites or electrode channels with which you can predict motor imagery. So we used a public data set for this, and it contains EEG samples from 9 subjects with disability and includes data corresponding to right hand and both feet motor imagery. So we tried to distinguish right hand versus both feet motor imagery, and we tried to see what features are actually responsible for predicting right hand and both feet motor imagery. Now, when we say 9 subjects, this doesn't mean that we have only 9 samples out here, because each subject goes through the experimental paradigm multiple times, or he has multiple trials that has gone through him. So we have approximately 10 to 15 samples for each subject that we have here, and this is a public data set, so it's available online. And then we have to clean the data as it's noisy. So we did artifact removal, which is another name for cleaning the data, using a pre-existing algorithm called ATAR. And that's how, we first clean the data. And so the methodology is something like this, that first of all, we have a person out here and we collect signals from EEG signals from different channels. So channels means these electrodes which are placed on the scalp of the person. And these signals are the EEG signals, random EEG signals, which I just drew. These are not real ones. So if there are n channels and we have, let's say, m data points, which means that for 1 second, let's say I have 1,000 data points, so n channels into 1,000 data points. And then first I'll do the artifact removal. And then what we did was we decomposed into different bands, which are alpha, beta, delta, and gamma. So we decomposed each wavelet into each wave of a channel into different bands, and we sliced the data using time windows and calculated event-related desynchronization and synchronization. So this means that, the power of the signal before the person was imagining the movement and the power of the signal after the person was imagining the movement. So the difference between these two, like while imagining and before imagining, is actually the ERDARS, event-related desynchronization and synchronization. Here, event being the point of start of the motor imagery or the motor movement imagination. Okay. So what we did was we calculated the motor imagery features using this formula, and we had a lot of features this time, right? So how do we, so if there are 4 bands and n channels and m data points, this is the number of features that we have in the data set for each subject's single observation. And what happens is that, this becomes very difficult to interpret with so many features, like which one is actually important, right? So, and this is the case with most biological signals, because what happens is that it's difficult to collect observations, and there are less observations but more features per observation, so it makes difficult to implement some kind of deep neural networks or some other heavy parameter loaded architectures on this kind of data. Now, so what we did was we used very simple algorithms like random forest, because these usually have lower parameters and they tune well to smaller data sets, and they're also interpretable, meaning that we can understand, like they're not fully interpretable, but we can somehow statistically analyze what are the importance of the features. So we use random forest, multi-layer perceptrons, 2D regressor, XGBoost, decision tree, and we calculated the precision of motor imagery detection using these algorithms, and we calculated the 95% confidence interval in each, and we also did some statistical analysis showing that the p-value, which is less than 0.05, showing that at least one of the classifier is significantly better than the others according to the 95% confidence interval. So we saw that across all the metrics, XGBoost outperforms most of the competitions among these algorithms, and so we decided to use XGBoost for our next work. So what we did was the main aim of our experiment was to have interpretable feature space analysis. So we took all the features and we saw that, the T3 channel with the beta lobe and starting from 0 second is very important. Also, the T3 channel of the beta band starting from 1 second onwards is also important. So these importances were revealed using mean decrease in impurity, which is a way of model specific way of interpreting the importance of variables in a random forest, which we used. And also we used a model agnostic method, which means that this SHAP analysis, which can be actually used for analyzing any kind of model. And we saw that similarly, the T3 beta band is very important. And this makes sense to us because what happens is that, the beta band has been widely recognized in literature for being responsible for motor imagery. However, the temporal lobe is not usually associated with motor imagery. Why? Because it's the motor cortex, another part of the brain. But however, we did find the temporal lobe is related, and I believe this is because the subjects were shown a auditory clue before, the stimulus began, before the imagination began. So T3 is located near our ears, somewhere here, and so the temporal lobes are located near our ears, and so that is why the sound auditory processing happens. So maybe that's why that could be a reason why different researchers are getting different channels and different bands important, because someone is giving them an auditory cue to start imagining movement, someone else might be giving them a visual cue to start imagining movement. So this we thought was an important part of it. And then what we did was we
Sorry,
did the
your time is finished. Please try to summarize and conclude.
Oh, thank you. Yeah, so we did the feature space analysis and we did see that, everything was like the features were separable. So with this, I would like to open the floor to questions and share my contact details so that if anyone wants to reach out or collaborate. And thank you for your time.
Okay, thank you. Dear participants, do you have any questions? Okay, let's go with the next paper. The title of the paper is Model for Generating the Structure of a Scientific Publication Using Generative AI.
Okay, hello.
Hello.
I will share my presentation.
Okay.
Okay. Dear colleagues, my name is Olganis Rashidov from the Technical University of Gabrovo, Bulgaria. Together with my co-author Fatma Rashidova, I will present our study entitled Model for Generating the Structured Scientific Publication Using Generative AI. In recent years, tools like ChatGPT have become common for editing text. Yet, the structure of scientific paper is not just formatting. It determines how the argument is built. This step is still difficult, especially for young researchers or when writing in second language. Therefore, we aim to support this exact stage. Even though we have well-known models such as IMRAD, in practice, authors often follow them superficially, copying structures instead of building them intentionally. There is still no intelligent mechanism that adapts the structure to the specific topic, methodology, and purpose. And this is where the proposed model becomes essential. The aim is clear and focused. We want to systematize how AI can support authors during the earliest and most conceptual stage, building the structure. The tasks follow a logical progression: define input, build the algorithm, demonstrate how it works, evaluate it, and finally, consider implications. The core of the approach is not to let AI write the article, but rather to use AI as an interactive tool for structuring. The model adapts to the author's intentions, the publication context, and the research field. This slide shows the block diagram of the algorithm. The model does not generate the structure once and stop. Instead, it allows iterative refinement. The author remains in control. The AI acts as partner in reasoning, not as replacement. Excuse me. This stage is essential because it defines the frame of the interaction. If the initial description is vague, the structure will also be vague. The model cannot guess the author's intention. We must set it clearly. Here, we are not giving content, we are giving form. This is where we say how the paper should be shaped, not what it will contain. The model now produces a structured outline based on the instructions we provided. It is important to emphasize this is not the final structure. It is the first draft, the foundation that we can critique and improve. Here, the human role is central. The author examines whether the structure fits the research logic, the methodology, and the message. AI proposes, but the author decides. This is the checkpoint. If the structure fits our intention, we proceed. If not, we refine and iterate. The key idea is that the author remains in control of the structural reasoning. The purpose of this stage is not trial and error. The better and more specific the author's instructions are, the stronger the next version of the structure becomes. This stage demonstrates that the AI is a partner, not an autonomous writer. At this point, we begin to converge toward the final structure. The model adapts according to the author's feedback, which allows flexibility across different research fields and publication formats. The SWOT step is optional but available. It helps the author see the structure not only as a layout, but as strategic academic choice. It can reveal missing balance, over generalization, or untapped potential in how the work is framed. Next stage marks the transition from planning to writing. Although the model contributes structurally, the scientific reasoning, interpretation, and arguments remain the author's responsibility. In other words, the AI shapes the framework. The author provides the science. This example shows how the author and the model work together. The author specifies the goal and preferred structure. The model produces an outline. Then they iterate. The key insight is that the process is interactive, not automatic. The model does not replace the author. It strengthens the author. It provides structure quickly, adapts to the research context, and is especially valuable in education and mentoring environments. And importantly, the author remains the one who makes the scientific decisions. The SWOT analysis shows that the model is strong in clarity, adaptability, and support for researchers. Its main limitation is that it requires thoughtful author input, which is expected in academic work. The opportunities lie in education and integration with writing platforms, while ethical consideration must be respected. The results show that the model is efficient, practical, and well received. Average generation time was under 15 minutes. Satisfaction was high, and all final structures met the author's intended research logic. In summary, the model enhanced the early phase of scientific writing. It supports clarity, saves time, and encourages reflective decision-making by the author. AI here is not the writer. It is the co-designer, the designer of structure. Every model has boundaries. Here, the key limitation is that the author thinking still drives the structure, which is how it should be. Looking forward, the model can evolve into an integrated academic writing assistant and a teaching tool. And this is thanks for your attention.
Okay, thank you. Are there any questions? Okay, let's go on with the next paper. The title of the paper is Prediction of Cyber Attacks Using Machine Learning in the Financial Sector Technical Review.
Okay, good morning.
Good morning.
Good morning. Okay, I share screen.
Okay.
Can you see?
Yes, you can start.
Okay. Well, good morning. Good morning, everyone. My name is Jago Diaz from the Technological University of Peru. It's an honor to be here today presenting our research paper titled Prediction of Cyber Attacks Using Machine Learning in the Financial Sector Technological Review. Well, We collaborate with Victor Moran Torres, Enrique Sanchez Portugal, and Jose Cornejo. In the next slide, the first is introduction. We have four topics: accelerate development of digital services in 2023. The credit card fraud generate losses of $32 billion. Traditional systems 76 accuracy versus machine learning accuracy of 99%. Finally, the traditional system show limitation against dynamically managed networks. From the methodology, we have divide in three sections: the context, the justification, the prisma diagram. In the context, in October 2024, Interbank suffered an cyber attack that exposed 3.7 terabyte of data from over 3 million customers, including personal and financial information. In the justification, in this case, highlights the urgency of applying a machine learning models to anticipate and mitigate threats before they occur, and reinforcing the relevance of this study on cyber attack prediction in the financial sector. In this topic, we have a prisma diagram. The identification, the selection is included. In this case, we have one database and records 251 papers. Uh, well, in this section we have results, and we have the methodology of Peacock. Uh, the first question or the first question with us in this investigation is in what types of transactional portals of financial systems are the prediction of cyber attacks being parsed? We have four results for this. Growing trend toward in customer-to-customer marketplaces and mobile banking application implemented in high-volume critical systems. Systems are highly vulnerable to cyber attacks, and the portals such as Mercury and European banks process over $1.2 billion per quarter. Well, in the classification, we have digital banking, payment processors, regulatory compliance portals, the e-commerce, customer-to-customer digital marketplaces, and others. Well, in the second question, we have how can the use of machine learning algorithms improve the early prediction of cyber attacks? Well, in this in these findings show that machine learning improves the accuracy and prevention of cyber attacks. We have random forest and SGBoost achieving accuracy close to 99%. Hybrid models allow for real-time detection and reduce false positive. Well, in this case, the classification ensemble models, random forest, and XGBoost, hybrid architecture, and graph neural networks. In this in this diagram, we have a radar chart with seven variables, and try to understand the performance of each model of machine learning. We have accuracy, real-time detection, data privacy, interpretability, adaptability, false positive reduction, and unbalanced data. In the third question, we have what differences exist in effectiveness between traditional cyber security methods and machine learning based methods. Well, in this have column groups of the chart. GNN improved the detection of systematic fraud with 66.7 accuracy. GNN deep learning identify complex patterns, imbalanced data, fraud causes. The classification with traditional methods, deep learning, imbalanced data, GNN for complex and supervised detection, privacy in machine learning, and hybrid approaches evaluation metrics. Well, with last question with Peacock, we have what improvements in prediction and prevention of cyber attacks are achieved through machine learning in banking problems in banking portals. Well, in this pie chart, we have a false positive reduction, complex pattern detection, real-time process less than 10 milliseconds. By IGRU is this algorithm adaptability to imbalanced data, combined solution like blockchain plus machine learning achieve 99 effectiveness and plus that reducing false negative by up to 92%. Well, models such as by GRU process transactions in 60 milliseconds. GNN with Lambda architecture detects more than 300 frauds in real time with 99.76 accuracy. Well, in this classification, uh, we have a high accuracy, fast processing, advanced detection, fewer errors, adaptability, and combined technologies. Well, in discussions, we have three topics, three results. Reinforcement learning reduce false positive by up to 31%, significantly improving fraud detection. In the second, we have a hybrid and deep learning methods outperform traditional methods, achieving F1 score greater than 92%. The future research should focus on federated learning and multitasking to improve adaptation for emerging fraud. Well, last we have a conclusions. We have a three important conclusion. We have a with my partner. And well, in the first, we have a machine learning models such as random forest and GNN prove highly effective, achieving nearly 99% accuracy and reduce false positives, substantially improving early financial cyber detection. From the second, the hybrid architectures and federated learning approaches increase overall accuracy and reinforce data privacy, establishing themselves as promising solution from financial fraud prevention. And for the last one, despite the progress achieved, models that must be validated in real world environments and integrate with reinforcement and multitask learning strategies to maintain effectiveness against dynamic and evolving threats. Well, for me and my partner is all. I hope you like my presentation and thank you very much.
Okay, thank you. Are there any questions? Okay, let's go on with the next paper. The title of the paper is Cardiovascular Disease Detection Using Embedded Software for Signal Pre-Processing, a Technical Review.
Warm greetings to everyone. I will present my research.
Okay, you can share your screen.
Okay, and my name is Jorge Luis Nostroza from the Faculty of Engineering at the Universidad Nacional Peru, and I am honored to present our study titled Cardiovascular Disease Detection Using Embedded Software for Signal Processing, a technical review. This work was conducted together with Crisel Mucha, Dr. Jose Cornejo, and Silvia Rodriguez. Our research explores how embedded systems and software are transforming cardiovascular disease detection, focusing on signal processing performance, diagnostic accuracy, and hardware efficiency. Cardiovascular diseases remain the leading cause of death worldwide, representing about the 30% of total global death according to the World Health Organization. In 2022, Central Asia registered the highest prevalence, reaching 11,000 cases per 10,100 inhabitants, while electrocardiograms or ECGs are key for diagnosing conditions such as arrhythmia, hypertension, and myocardial infarction. Access to specialized diagnostic tools is still limited in low-resource settings. Recent advances in artificial intelligence and the Internet of Things and telemedicine have enabled real-time arrhythmia detection, but the cost is high, and the bulkiness and dependence on stable connectivity continues to be the major barrier for widespread use. Despite technological progress, diagnostic systems remain expensive, heavy, and energy demanding. In fact, around the 90% of patients fail to identify their cardiovascular risk before experiencing a heart attack. Although AI, IoT, and cloud computing have advanced significantly, accessibility remains limited in remote or vulnerable areas. In this context, embedded systems emerge as an efficient and affordable alternative to these systems. Uh, this system can detect subtle patterns in ECG signals and perform on onboard signal processing, enabling autonomous or real-time cardiac diagnostic without relying on continuous connectivity. The objective of this review was to critically analyze the state of art of embedded software applied to cardiovascular disease detection. We examined how these systems process biomedical signals, the algorithms employed, their accuracy, and their energy efficiency. This research contributes by identifying key software and hardware strategies that make embedded platforms viable for medical-grade signals analysis, especially in low-cost and portable devices. The study followed the PRISMA methodology, ensuring systematic selection and transparent evaluation. An initial search retrieved 30 publications from Scopus between 2020 and 2025. After applying inclusion and exclusion criteria, we have 21 studies were selected in depth analysis. Each paper was examined according to the PICOP model, addressing 5 main research questions: which biomedical signals were used, what signal processing techniques are implemented, how these techniques compare to traditional methods, how effective the embedded devices are, and what environments they are applied. Among the retrieved works, the electrocardiogram was the most utilized signal, appearing in over half of the studies due to effectiveness in detecting arrhythmias, myocardial infarction, and cardiac activity. Other physiological signals such photoplethysmography, oxygen saturation, galvanic skin response, and respiratory activity were also analyzed to complement diagnosis. Several studies combine ECG with deep neural networks, enabling intelligent diagnosis even with portable sensors. This multimodal approach increases the reliability of cardiovascular monitoring in real-world scenarios. Signal processing methods vary according to the hardware type. Microcontrollers execute lightweight, low-energy operations, while digital signal processors handle complex algorithms efficiently. Common processing techniques includes digital filtering, such Butterworth and low-pass filters, to clean noisy ECG signals, wavelet and short-time Fourier transforms for time frequency analysis, and segmentation algorithms like Pam Tompkins to identify QRS complexes in real time. These optimizations enable continuous cardiac analysis with up to 34% energy saving and improved reliability across embedded platforms. Compared with conventional diagnostic tools, embedded signal processing systems demonstrate higher accuracy when integrated with on-device AI models, better noise resistance in mobile or wearable contexts, and greater accessibility due to affordable and portable hardware. For example, CNN-based ECG analysis on ARM Cortex processors achieved over 97% accuracy, while FPGA systems using PPG and deep learning models reached around 18% accuracy with ultra-low latency. Although performance may vary across platforms, embedded architectures show strong potential on reliable medical and streaming and mobile healthcare applications. Embedded devices equipped with optimized AI algorithms achieve remarkable performance level. Diagnostic accuracy exceeded 97% with energy consumption below 4.08 microwatts and interference times between 1 and 2 milliseconds. In addition, these systems demonstrate validated performance in both clinical and home-based environments. Such characteristics confirm that embedded architecture can provide real-time and low-power and clinically consistent cardiovascular detection. Embedded software for cardiac monitoring has been successfully implemented in several contexts. It powers wearable and portable systems from continuous home monitoring, IoT, and MIoT platforms, transmitting biomedical data securely. Clinical systems support specialists in arrhythmia detections and rural or high interference settings where signal stability must be maintained despite poor connectivity. This adaptability shows the potential of embedded health technologies to expand medical access in low-resource or remote environments. In conclusion, embedded software plays a crucial role in improving signal quality, diagnostic accuracy, and energy efficiency for cardiovascular disease detection. Through optimized filtering and transformation, ECG signals can be effectively cleaned and interpreted in real time. When combined with neural networks, these systems achieve near clinical precision with minimal computational cost. Future work should focus on real-world validation, cross-hardware compatibility, and design of hybrid AI-embedded framework to develop a next generation of cardiac diagnostic tools. This study highlights the potential of embedded signal processing to bring advanced cardiovascular diagnostic to portable and accessible devices. It represents a key step toward inclusive digital healthcare and the early prevention of heart diseases. Thank you very much for your attention.
Okay, thank you. Are there any questions? Okay, the title of the next paper is Service Automation Effects of Chatbot Implementation on Resource Efficiency and Business Performance in Bulgaria.
Good morning. I will share my screen.
Good morning. Okay.
Okay, you can see it, the
Yes.
presentation?
Yes.
Yes. Good morning to all of you. My name is Anna Todorova, and I am a PhD student at University of Ruse, Bulgaria. And I will present to you the paper with name Effects of Chatbot Implementation. In today's highly digitized environment, customer service is becoming a crucial factor in the sustainability of any organization. Customer expects services to be fast, accurate, and and available at all times, which puts significant pressure on traditional communication channels. This is where automated solutions such as chatbots come in, offering the opportunity for immediate responses, constant availability, and higher operational efficiency. So this makes the topics extremely relevant and essential for businesses seeking ways to enhance their customer experience. Chatbots are intelligent software agents that use natural language processing to understand and respond to user queries, simulating human conversations. Their primary role is to streamline access to information and services, replacing the need for complex site navigation or waiting for human support. By automating standard repetitive tasks, chatbots provide instructions, retrieve data, and guide users, significantly saving time for customers and also ensuring fast, consistent communication for businesses. Utilizing sophisticated NLP, they offer personalized recommendations and learn from the past interactions. This combination of automation and personalized service optimizes processes and also delivers a smoother, more seamless digital user experience. Despite their benefits in speeding up routine queries and reducing costs, chatbots face significant debate. They are often criticized for lacking the human element and failing to capture emotional nuances, making them unsuitable for complex situations requiring empathy and flexibility. A major criticism stems from their limited ability to understand imprecisely or emotionally formulated problems, leading to ineffective cyclical conversations driven by preset scripts. Also, many users strongly prefer human interaction for urgent or personal topics. Furthermore, technological issues and the practice of companies removing alternative contact channels force customers to use the bot, leading to frustration. This indicates that that chatbot implementation is not a universal solution and also requires careful design and integration. In Bulgaria, an increasing number of companies are implementing chatbots to optimize cost and enhance customer communication. Since the local market has its own specific characteristics, it is essential to examine the actual impact of these systems across various industries. The analysis of specific cases can reveal both good practices and challenges particular to the Bulgarian business context. This makes it possible to understand which models actually work and how technologies affect the interaction between companies and customers. So the main question at the center of this study is to what extent do chatbot applications contribute to increasing the efficiency of business processes and improving overall organizational productivity. For the purpose of the study, the method of multiple case studies was used, including companies from different sectors. Each case study is considered as a complete system with its goals, implementation processes, specific chatbot functionalities, challenges during its use, and observed results. By comparing the different case studies, common trends and recurring patterns are sought, which allow for broader and valid conclusions to be drawn about the effect of these technologies on business processes. The comparative analysis between the different case studies clearly shows that before the implementation of chatbot solutions, Bulgarian companies faced significant problems in customer service. One of the most common difficulties is related to unprocessed processed or delayed inquiries that arrived at night or outside of working hours. The lack of human resources during these hours leads to numerous missed opportunities and unfulfilled customer needs. Additionally, routine requests and administrative activities significantly burden the staff and make it difficult to respond quickly. Another significant problem is the high workload of employees during the day, which delays the provision of service and creates additional tension in the team. Some companies even experience an acute shortage of personnel, which makes it impossible to process all incoming messages on social networks and other standard communication channels. The study also shows that the implementation of chatbots leads to a complete transformation in both the operational work of companies and user experience. The most significant advantage is the guaranteed 24/7 availability. Chatbot provides constant communication and access to services regardless of working hours, which significantly reduce the number of missed inquiries. This is especially important for industries such as tourism or healthcare, where many requests are received in the late hours. The automation of routine tasks also makes a key contribution. Chatbots take over booking appointments, confirmations, changes to reservations, providing standard information and also answers to frequently asked questions. Thus, companies report significant man-hour savings and higher team efficiency. Additionally, an increase in new customers and reservation is observed thanks to improved accessibility and speed of communication. Consistent and accurate responses increase satisfactions, and the ability to search large volumes of inquiries helps to successfully manage peak periods. From a consumer perspective, the implementation of chatbots has led to a significant improvement in communication with companies. Before automation, customers often faced a lack of responses outside of standard business hours, delayed service, or difficulties in performing simple operations such as making an appointment or changing a reservation. These limitations create a sense of inconvenience and uncertainty, and in some cases lead to the refusal of service. However, after the introduction of chatbots, the user experience has become much smoother and more accessible. Customers receive immediate, accurate, and consistent responses at any time of the day. Despite the clear result, it is important to note some limitation of the study. The analysis is based on a limited number of case studies from the Bulgarian business environment, which limits the possibility of full generalizations to all industries. The sectors that were included have specificities that may not be applicable to more technical or highly regulated areas. Based on the analysis, it can be concluded that chatbots are a powerful tool for optimizing business processes and improving customer service. They successfully address key challenges related to staff shortages, high workloads, delayed response, and administrative difficulties. Through automated processes and constant availability, chatbots allow companies to maintain a high level of service, even with limited resources. The results also show that implementing chatbots is an effective approach for a number of Bulgarian companies looking for a sustainable way to increase their efficiency and competitiveness. However, successful integration requires careful planning, from correctly defined functionalities to providing alternative contact with a human operator when necessary. Combining automation with the human factor remains the most effective model. In conclusion, chatbot have the potential to be an important part of the future development of customer service in Bulgaria. They should not be perceived as a replacement for human labor, but as a complementary technology that expands the capacity of organizations and provides a new level of accessibility and convenience for customers. So, thank you for your attention.
Okay, thank you. Do you have any questions? Title of the next paper is Logical Numerical Modeling of Battery Energy Storage Systems for Modern Power Grid Integrations.
I'm sharing my screen.
Okay.
All right, good morning, everyone. My name is Bapadita Shah Chaudhary, and I'm going to present my work here. So the name of my paper is Logical Numerical Modeling of Battery Energy Storage System for Modern Power Grid Integrations. So let me start with the motivation behind this work. So right now, the grid is becoming more dependent on renewable energy sources like solar and like wind. So they are clean and promising, but here's the catch. So they are like intermittent too. So sun and wind don't follow our peak demand times, and this creates voltage swings, frequency issues, and generate instability in the grid. This is why our battery energy storage system, or BESS, become essential. So BESS works like a buffer. So when renewables produce more energy than needed, the battery stores it. When demand increases and renewable output drops, the battery fills the gaps. So here's the big challenge. Can we make the model like BESS in a simple but accurate way so that it can be used for practical grid analysis? So that problem actually is this kind of research that tries to solve that. So where's the research objective? So our main goal was to develop a logical numerical model using MATLAB or Simulink. So we wanted to model to be easy to understand, like modular and accurate enough to show real world battery energy storage system behavior. To test the model, we simulated three practical scenarios, which are like peak shaving, load shifting, and load leveling. These are the most common battery energy storage system applications in commercial energy systems. So what this work contributes? So first of all, we build a modular battery energy storage design, and the controller, the power conversion system, and the battery unit that are all independent blocks. So that means you can modify any part without breaking the whole system. Secondly, we want it to be an accessible model. So something that engineer, student, and even early stage researcher can use without need any kind of deep circuit level knowledge. So thirdly, the model is versatile. So it successfully handles all three major grid services I mentioned earlier. So overall, this model gives a fast and practical way to understand how battery energy storage system behaves in different applications. So here comes the quick overview of the system. That model has three main components. So these are the charge discharge controller. It's kind of brain who's actually which one is deciding when to charge or discharge. So the second one is the power conversion system, or like PCS. So it manages how efficiently energy flows between the battery and grid. And the third one is battery block, which represents the battery's voltage, like state of charge, power limits, and dynamics. So everything was developed in MATLAB or Simulink, so you can visually track how each block works or each block behaves. So here's the internal model architecture, like the main three core blocks over here. So this slide shows how internal architecture looks in Simulink. So each block interacts with other the clear input-output connections. So this modular setup gives both transparency and flexibility. So you can change battery size, controller logic like PCS rating, and immediately see how the system responds. So after that, the simulation scenario, to test that the model in realistic condition, we used a commercial binding load profile with 606 kilowatt peak load and roughly 8,970 kilowatt daily energy uses. So then we apply it to our BESS model to three scenarios like peak shaving, which reduces the highest load peaks, and secondly on the load shifting, which move energy from low price hours to high price hours, and the thirdly load leveling, which maintains a nearly constant load throughout the whole day. So these are the real world use cases in industry care about. So after that, let's start with the peak shaving results. So here we used a 720 kilowatt battery and with a 150 kilowatt power capacity. So the controller charges the battery during off-peak hours and discharges it during the high demand hours. And the result is we reduce the peak load from 606 kilowatt down to 500 kilowatt. That is about 17.5% reduction, which is significantly for utilities and industries because it cuts demand charges and reduces stress on the grid. So the state of charge pattern also confirms that the battery was used efficiently across the day. So next is load shifting. So here we use a bigger system like 3000 kilowatt capacity with the 350 kilowatt rated power. So the goal was to move energy from low cost hours to high cost hours, basically an economic benefit. So the system successfully shifted around 2021 kilowatt of energy. So if you are under time of use pricing, that kind of shifting can reduce cost quite a lot. So now the third scenario is load leveling, the consistent energy delivery. So we used here a 2000 kilowatt battery with 250 kilowatt of converter. Here the goal was to keep load steady around 400 kilowatt throughout the entire day. So this is the important for microgrid and industrial systems where stability and predictability matters. So as you can see, the BESS model almost completely flattened the original fluctuating load curve, which is around 400 kilowatt. So the next slide is on sensitivity analysis. So we also checked how battery size and PCS rating affect performance. So increasing the battery size or battery capacity by 20 to 25% gives sustainable benefits. So larger system, especially around 2000 to 3000 kilowatt, retain more state of charge at the end of the day. In some simulations, the end of the day SOC or state of charge went down from around 5.8% to more than 51%. This means the bigger system offers better operational buffer and flexibility, but the trade-off is cost. So sizing needs to balance performance versus investment. So after that, all over, we can say that the model is kind of versatile and easy to apply, and also the effective for feasibility studies. So it gives a practical way to test battery energy storage system for industrial and commercial loads without doing deep power electronic modelings. So it strikes a balance between speed and accuracy, make it a valuable decision-making tool for planning energy storage installation. So for the future work, to wrap up, we can say we develop a simplified yet powerful battery energy storage system or battery energy storage model that works well across multiple grid applications. It flattens peaks, shift loads, and levels profiles effectively. In the future, we have some plans to do add renewable models like PV and wind with that. So incorporate dynamic pricing signals and extend the model for hybrid storage system such as battery with the supercapacitor combination and so on. So that was from all my side, and thank you for all. Thank you all for hearing me. Thank you for your time. If you have any questions, you can let me know.
Okay, thank you. Are there any questions? Okay, let's go on with the next paper. The title of the paper is Research on Autonomous Driving Control Strategies for Rail Transit Trains Based on Intelligence Transportation Systems. I think the author is not here. The title of the other paper is Harnessing Artificial Intelligence to Optimize Decision Making and Social Value Creation in Philanthropy.
Hello, good morning.
Hello, you can share your screen.
Okay, thank you. Can you see my screen?
Yes, you can start.
Okay, thank you. Okay, good morning, everyone. So thank you for the opportunity to present our paper. I am Mahaning, and I would like to present our paper titled Harnessing AI to Optimize Decision Making and Social Value Creation in Philanthropy. So why we are doing this research is because currently nonprofit organizations face many challenges in assessing and evaluating their program and impact. So there are continuous demand from donors and investors to have tangible impact analysis. And on the other hand, society also demand greater transparency of information. And currently, there are AI trends that widely used in various sectors. However, adaptations in AI for nonprofit is still in infancy. So, why these trends? Because there are lack of knowledge and technical understanding to adopt this technology. So, this paper aims to analyze the current literature about AI adoptions in nonprofit and especially for data analysis to help in understanding how organizations utilize AI better as foundation of future research. So, the method to do the research is using bibliometric analysis and literature review. So, bibliometric is statistical method that performs quantitative analysis on research papers on specific issue using mathematical techniques. And literature review are also performed by thoroughly reviewing available literature to develop synthesis that complete analysis from bibliometric method to gain deeper understanding about the topic. So basically, this research using secondary data collection from Scopus database, and this keyword that used to retrieve data is which this title, which is artificial intelligence or data analysis or big data, and in AI, in nonprofit, philanthropy, or NGO. So based on the data retrieve, we see this trend of publications related to AI use in nonprofit organization, especially for data analysis. So the spikes start from 2024. So quite also when the era of AI coming. So the publication also is very still little. Yeah. So the total is not is under 50 publications until 2024. And for the publishing countries, United States leads the publication, which is amounted to 35%, and followed by Switzerland and Canada, China, and India. And most of publication type is book chapter type, and also followed by articles and conference paper. And when we analyze the co-authorship, and the co-authorship is actually refers to the number of co-authored documents by authors, we can see this graph, which shows that most of the author doesn't really collaborate yet in this topic of research. And from the co-occurrence keyword, we have this network, and it has some cluster of network here, which is 5 cluster of network. The first cluster is the red cluster, and some important keyword is human challenge and public-private partnership, which focusing the explanations on how the challenge on the human side be the challenge factor to implement AI and data analytics in private partnership. And the second cluster is the purple cluster. Some important keyword is data analytics and visualization. And the third cluster is blue cluster, which presents several prominent keywords such as big data, corporate philanthropy, and social responsibilities, which this cluster mainly focus on explaining the use of the big data in CSR program to measure impact. And the fourth cluster, which is green cluster, the prominent keyword is artificial intelligence, decision making, and finance, which focus in explaining the outcomes, especially in financial measures. And the last one, the yellow cluster, focus on using data to perform data analysis, program evaluation, and outcome assessment, which refer to sustainable development program. And based on our analysis, also we found 8 software categories that can be utilized in nonprofit to as their means for the data analysis and decision making. The first one is accounting and financial management, which propose to manage nonprofit accounting process with AI-powered insight, invoice processing, and fraud detections. Because basically it a bit difference between the accounting and financial report between the nonprofit and profit. Because basically in nonprofit, mostly the investment comes from the donor and investors, and it doesn't have like profitability or the profit as outcomes. So there are some of the software that match with this purpose, which is such as QuickBooks Online, Sage Intact, and so on. And the second one is software for the data analytics and visualizations, which aim to process and visualize donor trends, for example, campaign performance and social media engagement, which nonprofit organization can utilize widely used software such as Tableau, Microsoft Power BI, and Google Data Studio. And the third software category is AI and machine learning framework, which purpose to build predictive model for donor behaviors and program impacts that can be used by using TensorFlow, PyTorch, and scikit-learn. And the fourth is social media data collection, which aims to extract and analyze data from different platforms such as Facebook, Twitter, Instagram, using various tools such as Meltwater, Brandwatch, and Sport Social. And the fifth is database management, which to store and manage structured and unstructured data, such as using Postgre or MySQL and MongoDB. And the sixth is for ETL tools or extract, transform, and load tools. It can integrate multiple internal and external data. There are various tools available such as Talent, Apache, and Microsoft Azure Data Factory. And for the cloud service, to enable scalable AI processing and data storage, it can be used AWS, and Azure Blob Storage and Google BigQuery. And last is for the security and compliance tools that purpose to ensure secure data handling and compliance with donor privacy regulations. We can use Symantec data loss prevention, for example, Poronis and Cloudflare Zero Trust. So for the conclusion, we can see from the trend that a significant number of publications have increased compared to previous years, which indicates the beginning era of AI utilization to data analytics for the nonprofit organizations. So technology that already been mentioned before can help philanthropy to use, manage, and understand their data better. It also helps nonprofit to streamline their vision into measurable indicators that help them more precisely evaluate their impact. And lastly, the study found that most publications on this topic focus on donor behavior and fundraising, while fewer studies address ethical concerns, transparency, or AI governance in philanthropy. Yeah, I think that's all the presentation from our group. If you have any questions.
Okay, thank you. Are there any questions? Okay, let's go on with the next paper. The title of the paper is Performance and Sustainability Analysis of Power Distribution Systems with High Solar PV Integration.
Can you hear me well?
Okay, you can start.
Yes. Okay. So, good morning, everyone. I'm happy to present my paper titled as Assessment of Power Distribution System Performance with PV-based Replacement of Conventional Generators. And my name is Mohammad Shahin Alam, and I'm from Illinois State University, Illinois, USA. So, as all of you know, in any traditional energy systems, there are three different parts. One is the generating side, another is the traditional transmission lines, and the third one is the power distribution side. So this paper is mainly from the power distribution side, not the generating side as well as the transmission side. So what we did in this paper, we try to expand the traditional power distribution systems in a way that we integrate more renewable based energy resources like PV, and we try to minimize fossil fuel based generators. This area is kind of a hot topic at this point because everyone is working to increase the system efficiency. At the same time, they want more clean energy so that which is good for the environment. So for this research, we investigate the power distribution system operations across various US states. We select the states randomly, just randomly selection. Okay, so we try to find out several key parameters, metrics like transmission losses, energy generation operating cost, and environmental emissions, while we replace fossil fuel with the PV generators. So if we summarize the key findings, there are only two main aspects was considered for this research. One of them was to reduce the environmental emissions with solar adoptions, and another is the enhancement of overall power distribution systems performance, like operating cost and emission reduction as well. So then we compare evaluation utilizing distribution system models for those selected 4 states like Alaska, Arizona, Illinois, and Louisiana. Since, as you know, the solar irradiance may be different into different states, that's how we selected those 4 different states in a way that we selected 2 normally colder state and 2 warmer state, so that we can compare between those selected states. We also did some sensitivity analysis to validate the models. So this slide is about the mathematical model. As you see, there are 2 equations. The first equations, using the first equation, you can easily determine the solar energy input. And the second model you can use, you can find out the power from the installed solar power panel. And the parameters are given here. So this slide, you can find out the amount of fuel, that you can reduce while you replace those traditional fossil fuel with the PV energy, PV resources like the coal in terms of kilogram, and gas, and also the diesel in terms of gallon. So it's pretty straightforward equations. So this slide is representing how we can find out the emissions that was coming from the gas turbine, diesel, and coal generator. Traditionally, The coal normally emits more emission compared to diesel and gas turbine, and gas turbine and diesel are pretty similar, but which is less than a diesel. So those two equations basically you can find out the system loss and the operating cost. As you can see here, from the operating cost point of view, there are three parts. The first part is mainly coming from the main generating stations, and the third part when you will add the distributed generators, I mean PV into the systems. So after we analyze all the equations, that how we can find out the system emissions or operating cost while you include PV and replace the traditional fuels. Now we did some kind of results analysis to see how the system works. So before we see the main results, this is the solar radiation data into 4 different states. Since the solar radiation data will be different month to month, so rather than considering 12 different months, we consider 3 different periods, like during summer term, winter term, and year-round term. And those are the data is given here. So since we try to see how much energy we can save if we include solar, since solar is pure clean energy and it's almost free. With there might be some maintenance cost, but in terms of fuel cost there is no cost. So we try to find out the amount of fuel that we saved for gasoline, for diesel and the coal in terms of their own respective units, as well as in terms of dollars. And those two tables are basically representing the amount of fuel that we can save while we install PV with respect to the distributed generators, I mean fossil fuel-based generators. So these two slides are basically the data. Now we are coming to the main analysis and results. So before we add the PV into the distribution system, this is the base result for the inter-distribution system. For an example, the operational cost was around 8,000, loss was around 375, and emission was around 218. Now let's see if we can include the renewable energy and replace the fossil fuel, how we can get benefit in terms of operational cost, loss, and emissions. So as I described before, we normally selected 3 different periods during a year: summer, winter, and year-round calculations. So this is for the year-round calculations. As you can see, I mean, on Alaska, if you if you integrate the PV with fossil fuels, the cost is going to be 7.6K, which is less than 8K. Similarly, the loss is around 364 and emission is around 207, which is much less than the base case. Also, the similar results are showing on different other states like Arizona, Illinois, LA. But there are some difference between state to state, because as I mentioned before, the solar radiation is not the same for all the states. So that is the reason the results vary from one state to another state. So the rest of the 2 slides are basically the same. One is for only for the summer time, and this is only for the winter times. As you can see, we are not getting that much benefits on the winter time, because winter times normally Alaska, you may not get that much sunny weather, so you may not have that much solar energy from the sun. So that was the reason, even though you install in Alaska, maybe winter time you may not get that benefits. But you might get some benefit on Arizona, because Arizona is mostly sunny state, so there is an year-round almost sunny weather there. So that was the reason this analysis is very important to do it in different states, so that you can see where you can install solar and where you cannot, which one is not a good option to install the solar. So this slide is representing the sensitivity analysis. Since we selected 2 warmer states and the 2 winter states, we are now trying to find out the differences, the benefit differences. Like for an example, what are the operating cost differences between Illinois and Louisiana? It's only 24, and this is only for a day. And system loss is only 0.59. Emission is only 0.67. Even though it seems a small amount, but if you multiply it by 30 and even by year, that will be a huge numbers. And those 3 tables are basically same. One is for the summer time, another is for the winter time, and another is for the year round. So with that, I'm almost done with my presentation. So the conclusion is, again, we try to integrate PV and try to replace with fossil fuel based generators in the distribution side. And our objective was to find out how we can minimize the environmental emissions, system loss, and operating cost into the distribution systems because of those replacement. And since the weather is totally different into different states, we try to find out the differences about solar integration impacts between state to states. So this research will mainly help to planner and researchers in developing sustainable and renewable energy solution into different parts in the USA. So overall, from the analysis, it is clear that PV integration really enhances power distribution system performance and promotes cleaner energy goals. So I'm almost done. I'm done with my presentations. So thank you again for your attention. If you have any questions, I would be happy to answer any questions you have.
Okay, thank you. Are there any questions? Okay, the title of the next paper is Defect Detection and Cybersecurity Index, the Role of Computer Vision as a Digital Forensic Tool. Are the authors here? I think they are not here. And the title of the last paper is Label Efficient Press Ultrasound Lesion Detection Using a Tiny Transformer Encoder. I think again the author is not here. Okay, dear participants, we have completed all of the presentations. On behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress, and we hope to meet you in next Congresses as well. Now, I am ending the session. Have a nice day.
Have a nice day.